So now this project, I'm going to walk you through how they implemented the project. Um, the project, it's first of all, it's been implemented on Jupyter Notebook. But at the end of after going through the project, we're going to like talk about why it's not the best method of implementing. Yeah, it's good for experiments in Jupyter Notebook. But as a data scientist or a machine learning engineer, you should learn how to like write those .py files and like ensure that your models are built well. And the yeah, experimenting with Jupyter Notebook as well as maybe as a data scientist just getting started, it's really, really cool and it's still being used. And so this is not to like rule out interactive notebooks entirely. However, it has its own purpose. And so when it comes to production, writing modular, readable code is often not the best, especially when you're working in a team. And so um, we'll just spend some time to go through the project first, and then what we're going to do is we're going to rewrite, kind of refactor this project and that is in Jupyter Notebook and implement some of the best practices that we discussed, trying to make it modular, trying to see how we can make it like maintainable, something that is readable. Although it's still readable, yeah, because taking time to like go through to ensure that it's it's using good variable names and naming convention. So most of what will be seen in the other aspect is still going to be the same thing. However, we'll still have to implement some of the things we've mentioned, like the best practices. And so in order to achieve this like average booking precedent, we got our data from um, the Goodreads, I think from Kaggle. Yeah, from Kaggle. And the pre-processing, so there's the data processing, which involves both getting data, cleaning, um, and also exploratory data analysis, and then preparing the data for machine learning prediction and actually doing the prediction and choosing the best model, which is like evolution. And so, uh, yeah, I'm just going to walk through the prediction, sorry, data pre-processing. Um, these are some of the libraries, pandas, plotly, matplotlib, numpy, seven. And yeah, so this cell has all the data sets. So there are about 5 CSV files, which includes like a CSV file that loads the books.csv contains, which we're going to see later on. You have the ratings, the book tags, um, a CSV file that has books to read, that is books that were tagged to read by users. Um, you have the ordinary tags for books. You have the ratings for books. So like the different data sets, you have the books data sets, you have the ratings data sets, you have the books tags data sets. So they're in their raw form. Um, the reason why, like I said, the comments and everything is like this, and this notebook is for it to be easily digestible by everyone. And so this is a form of exploration. For the books tags, this is the first 5 rows. And for the ratings data sets, you have the book ID, the user ID, and the rating. And so for the same book, you have different users that rated them differently. And so this gives you the shape generally for all data sets. So moving on to cleaning, which is takes like most of the time as a data scientist. Um, so you have they have to import like the different data sets and perform several cleaning operations. Um, for the cleaning, for the ratings data sets, remove duplicates, keys, um, different data structures that are not, and also generated some features. Also for the tags data sets, did some form of cleaning. For the to read data set, same thing, did a lot of cleaning, and then did some merging of data sets to create just one data frame. And so you have just one data frame that has the different data set, and we join them on the book ID, which is common to all data sets. So after joining it, I did more cleaning to just because of discrepancies in some notebooks, and came out finally with the final like data set. Yeah, to prevent data snooping bias, they had to split the data set into the training and the test set before doing exploratory data analysis. And our target um, feature is the average rating. And so after clearing, yeah, went started the books rating, exploratory data analysis, starting with books rating. Um, this is the distribution of the average rating for the books for amongst the books rating. But this is like the average rating amongst all books, and like the frequency of this average rating. Sorry, for the books data, this is like just to understand the different features. There's like a correlation matrix and like a regression plot also for the average rating and the rating scam. So these are just like exploratory data analysis to better understand the data. And uh, this is also like a bar plot that shows the clean tags and the average rating. And so this just gives like an idea of the distribution. We're trying to see if we have like an imbalanced data sets and trying to understand the data better, the features that could form relationships, which is normal to for every data scientist to undergo for every data science project. And then the next is like preparing data for machine learning prediction. So divide data into training data, the training and validation sets, and did some more like checks kind of for like identifiers because we don't want them. We have to like take them out. So remove identifier for all, remove identifiers, columns that are identifiers. Yes, they do not add any value to prediction. Checking for missing data, and this is like a function that does that, and removing the missing values where they are, and also irrelevant features based on results from the EDA. We decided to remove some other features. And then moving more into like the encoding data for machine learning proper. You have your train set, your validation set, and the test set. Also, at this point, we want to identify categorical variables. And these are like, this is a function that helps us to check for categorical variables so that we can factor them out and also use them like to encode the um, categorical variables before feeding it into the machine learning model. And so yeah, this notebook does everything. So after encoding, we have to separate it back into like training, the validation, and the test side. Yeah. Um, and finally, getting the name of the features, the feature matrix, and the target vector. And finally, scaling data to ensure that it's not skewed. Like some values are more than, if you can observe some values here, like the rating scans are high, bookends. We have to like normalize the sorry, we have to scale the data. So we transform the train, validation, and test sets. Okay. Now for hyperparameter tuning and model selection. Um, so this is more like an experimental like project, and it was just like, well, let's see which of the models will perform really well. And so the experimentation here was with like five models, including logistic regression, decision trees, classifier, uh, random forex, XGBoost, and a multi-layer perception of and so using the package from sklearn, um, created the pipeline, um, got a predefined split cost validator, and created a dictionary parameter grids for the different parameters for hyperparameter tuning. And so this is the parameter grid for logistic regression. This is the parameter grid for decision tree, random forests, XGBoost, multi-layer perception. And for this project, grid search cross-validation is implemented to like find the best parameters. And I'm just going to run this notebook right now and to see, well, I ran it earlier on, but I'm just going to run it again. It's probably going to take some time. Um, okay. And this is the model, like this is where the best model is sorted like based on the, um, considering that it's a classification tax, we're using the F1 score as our scoring metric. And we're going to select the best model. So I think after it runs, we're going to see which of the models will be the best, give us the best score. And plot the future importance and generate prediction based on the test data. So this is like an overview of what it's. Now, while several of the best practices that were mentioned earlier on have been implemented here in terms of naming convention, and it's really difficult. Like the code is not modularized. Like it's not arranged in proper order, and you need to have like, especially as I mentioned earlier, it's you're working in a team with other persons, like other like software engineers and this and machine learning engineers. It's okay. Yeah, I think this is it's the running. So it is important that you take out your like experimentation and implement it in like a .py file and not an interactive notebook. And so while we are waiting for this to like complete running, to complete prediction, I'm going to open my VS Code where we are going to rewrite, like kind of refactor this into something that is also maintainable, but I believe that we'll be able to implement more of the software best practices, software engineering best practices we've talked about. So we can properly work in a team with others. And so the first thing we'd want to do is to there's a project directory. So while this is running, let's just talk about, let's get started on transforming this. How's the directory is going to be? So this this project, it's called Protocol School of AI Workshop. Is the Goodreads average rating prediction. However, I think I have it. I'll share the link to. I think I have to share the link to GitHub repository where you have it, so you can take your time to go through it. And so this is like the different, like trying to have different folders for you to organize your different artifacts and the the scripts, as well as even if you have interactive notebooks, because it makes it more organized. And so in this situation, you can implement like your Gits, you know, um, DVC, like data version control we talked about, Git also, as well as even creating, ensuring that you create like a virtual environment for you to work so that you don't um, yeah. So it doesn't interrupt with what you're doing. And so I'm just going to walk you through this project directory. So we have the data first. This is where we have like the raw data, like the book tags I talked about. Um, to read, tags, ratings, books, the CSV, books, the stack. Now, the reason why you're seeing this DVC right here now is because already I've done like some of the version, like data version control, and it's not generated the DVC file for each of them. In the course of the processing the data and one of the Python files, they had to like store data temporarily. So this is where we have it like called process data. Now this folder is for distribution. Like distribution, it's more or less like the final model. And so we're going to save our model to this, like we save all distribution and binaries in this folder. The good rate is the virtual environment that was created. Now for this project, um, it's always advisable to create like virtual environment or use like um in this project I didn't make use of container like maybe like Docker, but yeah, I created a virtual environment where I installed all my software so it doesn't affect my global um packages like installations. And yeah, I the name of the virtual environment is called Goodreads. There's also a folder for notebook. So as in as much as I talked about not having interactive notebooks, yeah. So with VS Code, you can also have like you can even make use of like your interactive like digital notebooks in VS Code, and so the exploratory part of the project is still and the cleaning phase is still in the interactive notebook, while the other part that involves the training has been abstracted sort of to like a .py file, and it's kind of easier to run experimentation even. So I'll just confirm that this has completed. Oh yeah, so um so the SG boost classifier gives the best prediction with an F1 score of 0.9525. And when after getting the feature importance to see the most important features, we have the tag clean favorites. The tag, the ones that are tagged favorites, as well as non-fiction, historical fiction as clean features, they came out as some of the top predicting, which is yeah, it's kind of interesting. Okay, so having done this, let's try to see how we can transform or do the same thing here. I'm just going to walk you through how this has been implemented. So I have the first part, like I said, the exploratory data analysis from getting the data down to cleaning data and up till this point of data exploratory data analysis. At this point, you have it in the notebook folder. You have it in the notebook folder. Yeah. Now, just before I go ahead with going through the presentation, yeah, just before I continue, I don't talk about uh the VS Code. Like it's a lot of people, yeah, there are a lot of um packages as well as extensions that are very that makes your product makes you working with VS Code really interesting, and I found it really easy. There are several extensions that I make use of, including like Python, the Microsoft Python, which helps with like linting and debugging. So it's very easy for me to see my errors. And yeah, so if you're not using it already, you should probably take a look and try to see how you can maximize like different extensions, maybe for Docker, also as well as for Windows sub Linux. Um, Subsystem Linux. Okay, now I made mention about creating virtual environment. Now I created a virtual environment for this project and installed all my dependencies, like all dependencies, all packages in the virtual environment. So I'm going to ensure that I am back in that environment, which is this, yeah, Goodreads. So you can see there is Conda, there is Goodreads, there is normal Python. So I'm going to be choosing um, the virtual environment. Now, one disadvantage of using like creating a virtual environment in your workspace is that it might interfere with your VS Code extension. So it's not yeah, I noticed it when I did that, and I had to like install some of my extensions. So yeah, I think it's really nice for you to maybe create the environment, maybe like two directories up or one directory above, and then you can still install everything that you need to install. So let's move in. Let's get started. So like I mentioned, you have your data, the raw data that has been imported here. So it's still the same thing that we've experienced before. Um, and there's nothing really different here. Data cleaning, preprocessing, and up until exploration. And now at the end of the exploration, the data is now saved as a pickle file. Now, pickle file, it's more or less like a serialization, like it's a package that you can use. Pickle mixin, you can install it also. It's a package that you can used to serialize files. It could be serialized objects in general. And so I find it really handy even when I handle like text data as well as um, decided to use it here also. But you can also save to CSV. And so these the training data, the training sets, the test sets, as well as the target feature is being stored temporarily in this processed folder. And then when you open the training folder and you come to train, all libraries, all imports or all necessary libraries that needs to be used in this train.py been placed on top. And so it gives more sense of organization. You don't have to like put at each point like different libraries. And to generate my cross-validation results, I just created the folder here also. And at the top of this train.py file, we read back the Pico file to get training data, the test data, and the target features. And so continued like the way we did. So you can see that most of these things are still here. I still need to do some refactoring because yeah, you can see that it's still more or less the same code that you can see there. And the interesting thing about VS Code is you can equally transform this to um, a cell. So for example, I have this. That's one thing I like about VS Code. So I can run this cell with using the hash and percent sign. I can run this cell and opens like a Python interactive interface where it's executed. Oh yeah, there's some error. Okay, so PD is not defined. Yeah, so we need to run that from the top. One of the reasons why interactive cell is very, very interesting. So pretty much you have the same thing here, but then there's a lot of abstraction. Like those functions, they are no longer, you can see that the notebook is a lot shorter. At this point, we have gotten to the end and we're saving our model. Now, the notebook, when we have the functions, remember the functions we used for identifying checkers, the functions we used for checking for um, um, categorical variables, as well as for checking for nans. You know, we had to like put them in a separate .py file. And so it's very easy for you to have them, all your functions in one place, like a helper function, .py, and import it here to use them. Now, another thing is if the function gets to be probably more related and it has more um, uh, yeah, if it's more related, probably with that, which is still possible, probably develop it into like a class or maybe like a module and import it here. But for now, it's just a helper um, module that it's imported and with all the functions that can be used directly. But it helps me for readability. So I understand that, oh, all the functions, and I can use these functions even for another project. If I'm coming back, these functions, they are like, that's one thing about having, making your code maintainable and reusable. You can copy these functions easily and take this file into another project if you think you want to without going to like the train.py and start looking for these functions. So it was one of the reasons some of those practices I was talking about. Um, then we talked about like doc strings, how it's being implemented here, um, ensuring that you use the description, the parameters, the return, what it's returning and the type that is returning. So I'm going to run this. I'm going to start with running the interactive notebook. And the Jupyter server local here, it's now running. And yeah, we have done that. Now, if we can move to the upper functions, we are already importing it to train.py, so we can move straight to train.py, and we can just go ahead and run it on the command line. Yes, we are sure that everything is going to be safe. So let's see. I need to be sure that I'm in the right environment to start with. Oh yeah, I need to close this and delete this and go back to selecting. Terminal. Good. Okay, awesome. So we are now in our environment. So I can do I can take a look at all the packages that have been installed in this environment using pip list. Gives a list of all the packages that have been installed in this environment. And then with this list, with another command, pip freeze, you can generate the requirement.txt file that I was talking about earlier on. So it's easy for you to like generate that file and with these packages. And so if you when your code is committed to like the repository and it's now merged and someone pulls it, the requirement.txt file would contain the necessary requirements, and then whichever machine it's working can whichever machine the code is implemented can um, the developer or data scientist can ensure that install it. And so in order for us to generate that file, requirements.txt file, we're going to use pip.pipfreeze. So so these are files. As you can see, initially it was a you can see the difference between both of them. So you have pfreeze shows you all the versions, the version number, the different packages. So we're running in a virtual environment. We are using pip as our dependency manager for dependency management. Um, you can generate a requirement.txt file. Now let's talk about version control. And before we go into version control, I just mentioned, like you can see that we are done running our exploratory notebook, and it's still the same results that we had as before. So there's no difference, just that it's now on its own. So I don't need to scroll. For example, I don't need to, if I want to look at the model code, I don't need to have like to go through a whole notebook to go to the bottom. If I'm looking at the export, I want to look at anything analytics, I just go to the notebook folder but it's more well organized now. So I'm going to run the py file to just ensure that our model runs, see if it runs, and we'll check the distribution folder to see if the model is created. So we have the CD, we have CD into the training folder, and um, I can train. This is, we can probably, yeah, so that works. So yeah, so that works. So we can now check for our model in the distribution. Initially we checked it, this folder was empty. So at the end of our train.py, we serialized the model using the pickle. And so this is the last part. After doing a test like an inference, like just to do the cross validation, we serialized the model to the distribution folder and called it a model. We wrote to this file, and now the model artifact is now in the distribution. So we have like if we need to do any form of direct inference, so we have our model here, which is cool. Great. So um that's another thing about, you can keep making adjustments to your hyperparameters, and you don't have to run the whole notebook, and you just work on your train because you have your code is now like modularized. So these are some of the benefits of like organizing your code and maintaining best practices. Something also that we had not talked about, or we have not talked about, is version control and testing. So how do we implement put in this project, like transforming it here? Um, so let's talk about version control first. Um, so this project is hosted on GitHub, and there's a README file, there's a license, it's like a general open license, and there's the git ignore. So because somehow I'm lazy and I didn't want to start looking, like I didn't have like a repository of git ignore file, like what I needed to exclude, I created the repo first on GitHub, and then I cloned the repo, the empty repo, or used like the template for Python git ignore, and so yeah, it gave me most of these by default. However, I added a couple of things that should not be that is not important. To start with, my virtual environment, I I excluded it from it being added to the code repository, so it's not committed, as well as my ID like VS Code. And so these are some of the things, the local history for VS Code and all of these were some of the things I added to ensure that it's not committed to code to the code base. These are things that needs to be in my local system. It doesn't need to be in the code base. So yeah, you can use, these are the changes that have been made, and you can make your commits here. Just commit and push or pull. However, I'm very like used to the terminal. Like I love making use of the terminal. So I could really just do a git patch here. and add everything. Uh, Add all and add a commit message and say made changes to training code, made changes to train.py, and yeah, I can decide to push to my repository, but to remote. Um, cool. So that's about like the source code versioning. But let's talk about the data versioning control. Now, how does it work? Now you can see that there are no longer changes, no new changes because I've done the I pushed that. Um, so how does data versioning works? So it works in a similar fashion. It works entirely with Git in the sense that it doesn't it ignores the data itself, but it creates like a hash file that is added to Git that stores the version history of that data. And that version history, that hash file, it's the d.dvc file that we saw in this repository. And so you see the bookstags.csv.dvc. This dvc file, it's the hash file and it stores the version history of this books.csv file, this bookstags.csv. And also with the bookstags.csv, doesn't get committed to like it takes it with this file that's already been created, the dvc file, the books underscore like the bookstags.csv along with the main data files are already in Gitignore. While these version files, like the DVC files, are not committed to the code repository. And if you need to push it, it's going to go to the remote. And so that's how it stores the version history of the data sets. It's really it's very easy to get started with. You can use Git batch also to just AVC init, just like uh, Git or like Git. And you can also like DVC add and then you add the files. There are no new files for me to add at this point, but let me see if I could make some changes and see if we can make some changes to some of it to the data sets. Let's see. So in this directory, I can go ahead and write the DVC add and specify the directory where I have that particular books tag, CSV, Twitter, um, all data, books underscore book tag, books, um, book tags, text.csv. and then it tracks the change. And so it's having done the DVC aspect, you also have to run it on Git to ensure that the version is also updated. So what DVC does is that it creates a cache file that stores the actual data, right? And then generates a hash file that it's now .dvc. And then this DVC file is not the one, it's now being committed and added to the actual Git repository. And so after making the changes to the actual file, it's now prompting me to add the actual, um, update the version history of this, of the changes we've made. And so you can, after adding, um, the message, data versioning, uh, yeah, data versioning. Now, one reason why it's good to, it's always advisable, also a best practice for you to commit as often as possible when you make sizable changes for you to be like when we talk about continuous integration. That is one of the practice also for you to be. It's easy for you to like roll back in an event of any change, or like if there is a need to change your code, or if there is like an issue. But if you've done a lot of made a lot of changes, maybe over like having several files up to about 25, or um, up, depending on, it varies anyway, the magnitude varies. But if you've made so many changes, sometimes while troubleshooting, it's really difficult for you to track the issue. And so it's always good when you make so little changes and that is substantial enough or that is significant, you just commit and ensure that even if you don't push to the remote repository yet, but always integrate. Like that's the idea behind continuous integration. So the last part we're going to be talking about is testing. So we talked about testing. Um, Now it's really tricky in this when I was rewriting this project, because I was looking for functions I would test, or like pandas, what I want, but it just illustrates testing, like unit testing in particular here. Um, the functions, the helper functions, we just did some like checking to see if it returns the data. So let's see the objective of our helper functions. The helper functions we have here, we want them to return a data frame of the categorical variables and the number of unique values. Um, In this one, we want a data frame of variables with none, like not a number, and their proportion of none and data type. This is just check if it's available. And the ID checker is to check if they are identification numbers or in the data set. And so a simple test to run this test, like to check if it returns. This test is not like the optimal test that you want to run, but the test implemented there is just to check if it returns um, the appropriate, if it returns, if the function returns a data type, like if the type of data is data frame, if it returns a data frame. Because when you look at the function itself, it should return a data frame, but when we talk about testing, especially when you are thinking through implementing like not just unit testing, but implementing testing from the aspect of test-driven development, you even have to, you're supposed to like, a lot of people recommend writing like theoretically, that's the approach, writing your test before um, writing the code. So you write so your test would fail. But the reality is that sometimes there are a few persons so that yeah, it's a good practice and it's always advisable. And most times I try it, but sometimes I end up writing my test afterwards. But this is a simple test. For doing the test, for implementing the test, we used the package called PyTest. And so what PyTest does is we create a separate module with test underscore the name of the test you want to use. And then for this case, we have the three functions. These three functions, test ID checker, test non-checker, and test car, categorical variable checker. Now, it's like normal convention for you to use starts with test when you're using the PyTest. And for this, I just generated two different data frames using a feature called PyTest features. Features. Now, PyTest features is like they're the special functions that keep track of like um, resources to manage definitions. And so in this case, this function is just creating a data frame one, and this function is creating data frame two. And then both functions, or in this case, data frames are being passed into the ID checkers. And then I'm just asserting to check if the results from the, the, the result from the first one, that is df1, is equal to the result from df2. That's if if they still give like data frames, which is the typical data structure of the ID checker data function. And so implemented it for these other two. And like I said, this is not the perfect test that should be done here, but it's just to illustrate testing generally using assert. So I'm going to I'm going to run this right now. I test and hopefully let's see. Uh, so it's the module detects, like it runs through the code and sees detects the test underscore helper, knows that like there are tests there, and then it does run this test. And fortunately for us, is all three tests passed. But let's try to see how we can make let's try to see how we can make it break, or at least one of them. I don't think it's going to still break, but let's see. Let me try something. Yes, it's a frame. So let's see. We're going to run this again. So only one failed and two passed. And so this is just like an example of how you can write unit tests for function just to ensure that it's returning what you're expected to do. And so with this, I think we've covered, implemented most of, if not all, what we talked about in terms of best practices. And so I'm going to mix the code, and I don't think there's anything left. So yeah, we have it in a remote repository. We haven't done this, like we can see how it's easy to like navigate between doing tests. You can even do tests here, manage your data versions, as well as organizing your environments, a virtual environment so someone else can make use of your code, so make use of like packages. And so that's one reason why it's important for us to implement these practices. Because this is just like a makeshift like transition, trying to refactor what we already had in the notebook into like a modular and a reusable and maintainable code. So to wrap things up, I want us to take a look at there are other cloud-based self-management services that are not mentioned here. Yeah, like I said, I made mention of making use of like open source platforms at this point, like things that are easily reachable. But then with services like Azure Machine Learning, IBM Watson, Amazon SageMaker, you can make use of like it's like a machine learning studio, and you can run like notebooks, and you have like containers. You don't have to manage dependencies. It does everything for you, which makes it pretty easy. But under the hood, most of these things like managing dependencies using containers like Docker, Kubernetes, like container registries, they're all taking place. And just to give us an example like of one of these services, particularly the logical structure of Amazon SageMaker. So you have the um, AI developers, like or the data scientists or the machine learning engineers, and you have Amazon SageMaker. So Amazon SageMaker, it's in it's like the three major areas. You have the notebook instance, which is like a VM. You have the training and tuning, and you have the hosting. So the hosting part, like it's where you do inference and like try to host your model. Training and tuning, that's where under the hood everything happens. The model is just the notebook, sir, is just like a top layer that you can interact with. However, the training and tuning takes place in like a lot of there are a lot of packages and SDKs that are used. In order for you to be able to use Amazon SageMaker, you have to have the rights, um, IAM role, which is like identity management, as well as the key management services like encryption. Data is stored in S3. So these are all services like the whole idea of like SageMaker, Amazon, Azure Learning Studios to explain that or let us know that there are several services running at the background, making up this major service that we're using now, maybe like Learning Studio or Watson. There are several services. And so S3, Amazon S3, you can store your data as well as your model artifacts, like your final model. And then you have Amazon ECR, which is a container registry, where you have like already made, like already installed uh, deep learning frameworks like PyTorch, TensorFlow, and you can call up any of them and use any of the services. Of course, CloudWatch for you to be able to monitor your training jobs and how it's going. And so you have a notebook instance, and there are several example notebooks that can be modified for you to do your training jobs. And the the data is streamed from S3 into, even though you are controlling, you like initiate the commands from the notebook instance, the streaming of the data takes place from S3 into your training and tuning, where the training actually takes place. While your model artifacts, which is like the final model that has been built, it's sent like it's linked to your hosting, which can be a real-time inference endpoint. We might just show like, oh yes, this is a test data, this is a predict, right? Or you might, if you have like large data sets and you need to do like develop an API, probably you need to do like some batch transformation so that you can connect it through like using AWS Lambda to Amazon Gate API gateway to expose for maybe consumers, maybe to the end users also. Um, One thing I didn't make out clear in the demo we did right now is that we didn't do like we didn't have like an endpoint like an API. We're not developing an API. It's also something like this is what you have to do. Like maybe you have a developer, or you can even develop the API like you can maybe using Flask or Django. With the model artifact that you have, you can develop a backend API using Flask. However, Amazon makes it really easy with batch transformation. You can write scripts in AWS Lambda and you have it exposed to your API. Then the heart of it, it's in the training and tuning. So the data, it's a model. Data is you have everything runs in a container, right? And so the data is streamed into like the container. You have your log metrics, which you CloudWatch, you can view from CloudWatch. And then in order for it to be processed very well, of course, you have to introduce like distributed processing and high performance computing using like the library like CUDA to make use of like high GPUs and like deep learning framework like PyTorch. And then there's usually like an SDK, which is a software development kit that contains everything like the boilerplate, the model training and everything for SageMaker. And so while you it becomes really easy for you to make use of SageMaker on the notebook, the whole like work happens in this container, right? And so it makes it really easy. Like that's one advantage of using like cloud services. However, this is still like it's still important for you to understand like, oh, this is how it is right now, and this is how it's used in the cloud services. So yeah, so that concludes this workshop. I hope we've been able to learn a lot of like have some key takeaways. First being that we work in a team with other engineers and managers to deliver a complete solution, and data scientists do not work alone. And we all should be able to write clean, reusable, maintainable, as well as like codes that can scale easily. So it's something that with practice, understanding that this is important, and then taking time, like learning testing, learning how to uh, version your code well and use the right um, naming conventions, makes your code readable, maintainable, and also improves your code readability and maintainability. But thank you so much, and I look forward. I hope if you have any questions, I don't know, you can reach me on Twitter. I think yeah, or yeah, you can reach me on Twitter the or LinkedIn, and I'll be happy to discuss with you. So thank you.